In this video, I'm going to explain about a few artificial intelligence AI related terms. Let me first start with what is an AI model. An AI model is a computer program that learns patterns from data and makes predictions or generates responses. That means first we have to train the AI model using data. Then the trained model will be able to make predictions. Some AI models are trained from scratch using raw data, and we already have a lot of pre-trained models also, so that we can start doing the development quickly without spending time for training the models. Okay, but we have to do some kind of fine-tuning to make it work for us. So next, pre-trained model. So pre-trained models, as I said, there are a lot of pre-trained models are there, like BERT for NLP task, natural language processing, and Whisper for speech recognition, and DALI for image generation. Okay, so these kinds of pre-trained models are trained with a lot of data, huge data with huge power, computing power. We need not spend that kind of effort for getting that model. So we can just fine-tune the model for our own requirements, and then we can start using it. That is the next thing, fine-tuning. So fine-tuning is the process of taking a pre-trained AI model and training it further on a smaller specialized data set, our own data set, to improve its performance for a specific task, our own task. Okay. For example, the general chatbot like GPT can be fine-tuned on legal documents to provide more accurate answers to legal questions. Similarly, image recognition model can be fine-tuned on medical scans to detect diseases more effectively. The next one is, what is inference in AI? Inference is the process where an AI model applies what it has learned during training to generate an output or make a decision. So basically it's prediction or using the trained model. Whenever we say inference, that means we are going to use the trained model for our purpose. Okay, so the examples are when you ask ChatGPT a question, it analyzes the input and generates a relevant response based on its training. Similarly, a self-driving car uses inference to recognize traffic signs and make driving decisions in real time. Next question is, what is a data set in AI? A data set is a structured collection of text, images, numbers, or other types of data used to train and evaluate AI models. So whenever we do the training of AI model, we need to have a good quality data arranged in a proper way so that training process is effective. And once after completing the training, we have to evaluate, test the AI models. For that also, we have to prepare data. So all these data things together called as data set. Okay. Next question is, what does bias in AI mean? So bias in AI is a very key topic because the AI model can be trained with data, right? But in case if the data is having some incorrect information, that functionality of AI model will be not correct. Okay. So if there are any issues with the data, it will reflect in that model's performance. It is called as bias. Then what is zero-shot learning? Zero-shot learning allows AI to handle tasks it hasn't seen before. For example, if a chatbot correctly answers a question on a new topic without specific training, it is using zero-shot learning. For example, if you are using a model which is not trained with the zebra images, but it is able to detect zebra image as zebra, then it is known as zero-shot learning. So basically, it will be using the text descriptions to identify. So without the image training, it will be able to do that. This is known as zero-shot learning. Then what is neural network? Neural network is a type of AI model designed to mimic the way the human brain processes information. It consists of layers of interconnected artificial neurons that learn patterns from data. Each neuron receives inputs, applies weights, and passes the result through an activation function to make decisions. Neural networks are widely used in deep learning for tasks like image recognition, speech processing, and language translation. So some examples are CNNs for image classification, convolutional neural networks, CNN means, and RNNs for speech recognition. So it's basically like it's trying to copy the human brain activity. Okay, so the weight in the sense internally based on the training data, it will apply the weights so that the loss will be less. So it's basically something similar to our biological neurons. Biological neurons, that information is based on the uh, strength of the connection between the neurons, right? So same concept is applicable for this artificial neural network also. Then what is tokenization in AI? Tokenization is the process of breaking text into smaller parts, tokens, so AI can understand it. For example, AI is powerful. Might be split into AI is powerful. AI processes these tokens instead of full sentences. So usually in case of ChatGPT, a token will be around 4 characters. Then what is generative AI? Generative AI is a type of artificial intelligence that creates new content such as text, images, music, or code rather than just analyzing existing data. It learns patterns from large data sets and generates output based on input prompts. For example, ChatGPT creates human-like text responses. DALL-E generates images from descriptions, and MuseNet composes music. Generative AI is used in creative writing, design, and automation to enhance productivity and innovation. So this generative AI, Gen AI, is playing very important role these days. Okay, that large language models, LLMs like ChatGPT, that GPT-4 models, they are trained with a lot of data. Instead of training the model by ourselves, we can just start using that kind of LLMs using API, and then we can create our AI applications. Okay, so generative is playing important role these days. What is hallucination? AI hallucination occurs when an AI model generates false, misleading, or nonsensical information that sounds convincing but isn't true. This happens because AI models predict responses based on patterns in their training data and make guess when they lack accurate information. For example, a chatbot might invent a fake citation or provide incorrect historical facts. Reducing the hallucinations requires high quality training data, better fact checking, and techniques like grounding AI responses in verified sources. So basically, it is the inherent nature of the AI. Okay, so as of now, there is no solid way of preventing it. If you are familiar with using ChatGPT and Gemini, you might be knowing this. Sometimes for a small simple questions, ChatGPT or Gemini will be giving some wrong answer. The hallucination is a very major problem in AI. But for handling this, we have different approaches. For example, prompting tricks like chain of thoughts and RAG, retrieval augmented generation. By giving some external data using RAG, we can just try to mitigate the hallucination issue. Okay, but still it's a major issue. What does overfitting mean in AI? Overfitting happens when an AI model learns patterns from training data too precisely, including noise or irrelevant details, making it perform poorly on new unseen data. It is like a student memorizing answers instead of understanding the subject. Overfitting can be reduced using techniques like regularization, dropout, data augmentation, and cross-validation. Overfitting is like, say for example, we will be having training data for training the model, right? That model will be like fully trained for best suitable for the training data. So if you use the training data for the testing purpose, it will be working properly. Okay, 100% confidence like that it will be giving. Okay, but if you are going to use a similar image but not exactly same as training, in that case it won't work. Okay, so it will be working perfectly for the training images, but it won't work for test images or any kind of our actual usage images. Okay, so for that we have to reduce this overfitting. Okay, so there are various approaches. Data augmentation in the sense, say for example, if you are going to train the model with a few images, data augmentation in the sense it will be like flipping the image, creating mirror image, changing the colors like that. We can do some kind of processing, and then we can expand the training data. With that expanded data set, we can train the model to avoid overfitting. Another reason for overfitting is if we use more than record hidden layers or number of neurons. Okay, so over usage of neurons also will cause overfitting. Okay, and then what is underfitting? Underfitting occurs when an AI model fails to learn meaningful patterns from the training data, leading to poor performance on both the training set and new data. This happens when the model is too simple or lacks enough training time to capture the underlying relationships. It is like a student studying too little and struggling with both practice and real test. Underfitting can be addressed by using a more complex model, increasing training time, or providing more relevant features in the data. Underfitting in the sense the model cannot work properly even for the training data itself. That means the data is not that much good and the model is not having the ability to process it properly and the training time is not enough. Okay. In that case, we got to use some proper good model, complex model, and we have to increase the training time. Okay. And in the training data, we have to add more features. Okay. So in the training data, in the sense, each that data set will be having features and labels, right? I'm just telling a simple example. So in that case, the number of features or quality of that features will be should be increased to avoid underfitting. Then what is transfer learning? Transfer learning is when an AI model trained on one task is reused for another similar task. For example, your model trained on general images can be fine-tuned to identify medical scans. Okay, it can help us to save a lot of time. We need not do the training fully again. Then what is embeddings in AI? Embeddings are numerical representations of words, images, or other data that help AI models understand relationships and similarities between them. They convert complex information into dense vectors in a way that preserves meaning. For example, in a word embedding model, the word king is mapped to a vector close to queen, capturing their semantic relationship. Embeddings are widely used in natural language processing, recommendation systems, and image recognition to improve AI performance. So normally we will store the embeddings in vector databases. Okay, it is very much useful in retrieval augmented generation (RAG). So it's kind of semantic meaning. It's for keeping the semantic meaning. Okay, it will be useful for semantic search also. What is vector database? A vector database is a specialized database designed to store and search embeddings. It enables AI models to quickly find similar images, documents, or text by comparing vectors based on their mathematical proximity, something like cosine similarity like that. Okay, this makes it ideal for tasks like image recognition, recommendation systems, and semantic search. Popular vector databases include FAIRS, provided by Facebook, Pinecone, managed vector database, and ChromaDB. It's an open source. Even we can use it in our local machine. What is natural language processing? NLP. NLP is a branch of AI that enables computers to understand, interpret, and generate human language. It powers applications like chatbots, voice assistants, Siri, Alexa, language translation like Google Translate, and sentiment analysis. NLP combines linguistics and machine learning to help AI process text and speech in a way that feels natural to humans. So whenever we use AI application like ChatGPT, we can ask questions in a natural way using languages like English. What is supervised learning? Supervised learning is a type of machine learning where an AI model is trained using labeled data, meaning each input has a known correct output. The model learns by mapping inputs to the correct labels and improving its predictions over time. For example, training an AI to recognize cats and dogs involves showing it images labeled as cat or dog, so it can learn to classify new images accurately. Supervised learning is widely used in image recognition, speech recognition, and spam detection. So almost all the traditional machine learnings are using this approach. Okay, so we got to just label the data, and then we have to use that labeled data for training the model. Okay, what is unsupervised learning? Unsupervised learning is a type of machine learning where an AI model discovers patterns and structures in data without labeled answers. Instead of learning from predefined categories, the model identifies hidden relationships such as grouping similar items together. For example, in customer segmentation, AI can cluster customers based on purchasing behavior without being told which group they belong to. Unsupervised learning is commonly used in anomaly detection, recommendation systems, and data compression. So in case of unsupervised learning, we need not specify the labels. It will find the patterns automatically. What is reinforcement learning? Reinforcement learning, RL, is a type of machine learning where an AI learns by trial and error, receiving rewards for good actions and penalties for mistakes. Over time, it optimizes its decisions to maximize long-term rewards. RL is widely used in robotics, game-playing AI, example AlphaGo, self-driving cars, and personalized recommendations. So basically, it's like giving feedback kind of stuff, right? So if it is behaving correctly, then it will be rewarded. Otherwise, penalties for mistakes. What is LLM? LLM, it's a very key thing. Okay, it's a large language model. What is explainability in AI? Explainability refers to how well we can understand and interpret an AI model's decisions. Some AI models are like black boxes, making decisions without clear explanations, while others provide insights into their reasoning. So this explainability is becoming an important factor from the perspective of ethical perspective, regulations perspective. So it is important to know how the AI is internally taking decision about the output, why it's giving that output, that kind of information. Okay, but there will be some trade-off. If you're focusing on that thing, the efficiency of effectiveness of actual working may be reduced. What is deep learning? Deep learning is a subset of machine learning that uses artificial neural networks with multiple layers, deep neural networks, to process data and learn complex patterns. It excels at tasks like image recognition, speech processing, and natural language understanding. Deep learning powers advanced AI applications such as facial recognition, self-driving cars, chatbots, example ChatGPT, and medical image analysis. So deep learning, it's kind of a neural network. Okay, what is a large context window in AI? Large context window means an AI model can remember and process more words in a conversation or document at once. For example, a chatbot with a small window might forget earlier parts of a discussion, while one with a large window can maintain context better. So in case of ChatGPT, if you are discussing with ChatGPT, it will be remembering your previous questions also, right? So if you are asking a question about your computer, then you can ask about it further without specifying the computer, right? It is able to recognize your question properly because it is able to maintain the context window. So if it is a large context window, means it will be keeping many number of previous questions or discussions, right? So whenever LLM is specified, they used to specify this context window also, so that we can understand their performance. What is few shot learning? Few shot learning allows AI to learn a new task with very few examples. For instance, if you show an AI just a couple of labeled images of a new object, it can recognize similar ones without extensive training. So in case of few shot learning, we need not do a lot of training. Just showing few examples will help. Even in case of prompt engineering, like for using ChatGPT something, in the prompt itself we can give some examples and then we can ask questions. Mostly ChatGPT will be able to answer our questions. What is multimodal AI? Multimodal AI can process and understand different types of data like text, images, and audio together. For example, ChatGPT-4 can analyze both text and images in a conversation. GPT-4 is a multimodal model. So we will be able to handle both text. We can ask questions. We can ask questions by speech. Okay. And we can ask to generate images also, and we can upload the image and we can ask questions based on the image. Okay, what is computer vision? Computer vision is a field of AI that helps machines interpret and analyze images and videos. It is used in applications like facial recognition, self-driving cars, and medical images. It is also an important field. Okay, especially in self-driving cars, it plays an important role, and medical imaging also, it's a growing field. Computer vision techniques are performing better than the radiologists in identifying the diseases from the scan images. Okay, then what is pre-training versus fine-tuning? Pre-training is when an AI learns general knowledge from a massive dataset before being adapted for a specific task. Fine-tuning is the process of further training the AI on a smaller, specialized dataset to improve performance on a particular task. Pre-training in the sense, if a image recognition model is there, we can fine-tune it for specifically identifying the medical images. Okay, so it's a good way of balancing both things. The pre-training, that huge dataset will help in some way, and narrowing down our specific field with a fine-tuning dataset will help in some perspective. So it's combining power of both things. What is data augmentation in AI? Data augmentation is a technique used to expand a dataset by modifying existing data. For example, in image recognition, flipping, rotating, or changing brightness in images helps AI models learn better without needing new data. So if you observe the YOLO model training, you can find this thing. So even if you use some 10 images for the training purpose, If you go through the files created by YOLO model, you can find a lot of images. Some of them are flipped, some of them are like mirror images, rotated images. Okay, so just by having very little data, the data augmentation process will increase the data set. What is a loss function in AI? A loss function measures how far the AI's predictions are from the correct answers. AI models adjust their learning based on the loss function to improve accuracy. So it's a key thing. Okay, so whenever measuring the performance of accuracy of the model, the loss function gives the detailed support the error, basically the error. So based on that value, that model will be changing their weights. What is gradient descent? Gradient descent is an optimization algorithm that helps AI models adjust their internal settings, that is weights, to minimize errors and improve learning over time. It's something similar to backpropagation algorithm, right? What is model drift? Model drift happens when an AI model's accuracy decreases over time because the real world data it encounters has changed from the data it was trained on. This often happens in fraud detection and recommendation systems. So it's a deviation of model's output. Okay, it is because of the usage nature. So in case of recommendation systems, if the viewers are viewing in a different way, then obviously the model's output, previously trained model, will not be best suitable in this new scenario, right? So it is known as model drift. What is catastrophic forgetting? Catastrophic forgetting happens when an AI model trained on new data forgets what is learned from previous data. This is common in deep learning models that don't store past knowledge effectively. So if you train the data for cat, then after some time, if you train it for dog, then it will forget the identification of cat. So for that, we can follow different approaches. Whenever we train the new data, maybe we can train with the previous thing also, or a lot of different approaches are there. Okay, what is explainable AI? So it is about giving detailed support how the model is working and why it is giving this output like that. Okay, so it will help to improve the trust and accountability. What is reinforcement learning with human feedback, RLHF? It is a technique where AI is trained using human feedback to improve its responses. This is how models like ChatGPT are fine-tuned to be more helpful and accurate. So whenever you use ChatGPT, you will be having that thumbs up and thumbs down buttons, right? So it's like by clicking that buttons, you are giving your feedback. Okay, so it's reinforcement learning with human feedback. What is federated learning? Federated learning is a privacy-focused AI training method where data remains on users' devices instead of being sent to a central server. AI models learn from distributed data without compromising user privacy. So it's like keeping the training data on the user's device itself. Okay, instead of centralizing it, we are keeping the distributed system. What is a transformer model in AI? A transformer is a deep learning model architecture designed to handle large-scale language processing tasks. Models like GPT, BERT, and T5 use transformers to understand and generate text. So mostly these transformer models revolutionized that LLM, right? Because they are able to process all the text simultaneously. What is a knowledge graph? A knowledge graph is a structured representation of information that connects concepts and relationships. Google search and chatbots use knowledge graphs to provide relevant answers by linking related topics. So it's like connecting the information, like a node, that kind of stuff. What is retrieval augmented generation, RAG? RAG is an AI approach that improves the responses by retrieving relevant information from an external database before generating an answer. It helps chatbots provide more accurate and up-to-date responses. In case of RAG, apart from sending our prompts to the LLMs, we will be able to send some external data also along with the prompt, relevant external data. So for that retriever model is working. For that, we have to use the vector databases like ChromaDB or Pinecone. So with this setup, the RAG will be able to improve the accuracy. What is an AI accelerator? AI accelerators like GPUs and TPUs are specialized hardware designed to speed up AI computations, making training and inference faster. It's a hardware related stuff. Okay, so that AI training and inference can work faster. What is Edge AI? Edge AI runs AI models directly on local devices like smartphones and cameras instead of relying on cloud servers. This allows for faster processing and improved privacy. So in case of Edge AI, the models will run on the mobile phones itself. What is quantization AA. Quantization reduces the size of AA models by using lower precision numbers, making them run faster and more efficiently, especially on edge devices. So quantization is helping to achieve this edge AA. What are parameters in AI models? Parameters are the internal variables of an AI model that are learned during training. They define how the model processes input data to make predictions. For example, in a neural network, parameters include weights and biases that connect neurons. The more parameters a model has, the more complex it can be. When you hear about models with billions of parameters, for example, GPT-3 with 175 billion parameters, it means the model has a vast number of internal variables, allowing it to capture intricate patterns in data. So in case of more parameters, then it can work better. What is precision in machine learning? Precision is a metric used to evaluate the performance of a classification model. It measures the accuracy of the positive predictions made by the model. So these precision and recall, FN score, that kind of metrics are very much important. These metrics are very useful in evaluating the quality of the model, right? So precision is like it's kind of accuracy, okay, indicating accuracy, okay. If your model predicts 100 emails as spam and 90 of them are actually spam, the precision is 90%. So the formula is precision equal to true positives, that is 90 of them actually spam, right? So 90 divided by true positives plus false positives, okay. So 90 by 100, 90% precision, okay. High precision means the model is good at avoiding false positives, okay. And the recall, it is also called as sensitivity. It measures how well a model identifies all relevant positive cases. For example, if there are 100 spam emails in a dataset and the model correctly identifies 80 of them, the recall is 80%. High recall means the model is good at finding most of the positive cases. Precision focuses on accuracy of the positive predictions, that is, avoiding false positives. Recall focuses on capturing as many positive cases as possible, avoiding false negatives. So basically sensitivity, right? In a medical test, high precision means most positive test results are correct. High recall means most actual cases of the disease are detected. Often there is a trade-off between precision and recall, and the right balance depends on the use case. What is the FN score? The FN score is a single metric that combines precision and recall. It is the harmonic mean of the two and is useful when you want to balance both metrics. The FN score ranges from 0 to 1, where 1 is the best possible score. It is commonly used in classification tasks, especially when the dataset is imbalanced. What is a confusion matrix? Confusion matrix is a table used to evaluate the performance of a classification model. So it is like basically helping to calculate metrics like precision, recall, and accuracy. Okay, accuracy measures the percentage of correct predictions made by the model. So basically accuracy equal to true positives plus true negatives divided by total predictions. While accuracy is a useful metric, it can be misleading in imbalanced dataset. For example, when 90% of the data belongs to one class. In such cases, precision, recall, and FN score are more informative. What is a loss function? A loss function measures how well an AI model performs by comparing its predictions to the actual values. So basically, it's a error, right?